Alright, so in our last video we learned about something called end behavior, and by itself, end behavior may seem kind of like, why bother doing this? Why name this? But it turns out that if you can kind of conceptualize what's going on with end behavior, you can recognize a lot of polynomial graphs and kind of see what they're going to look like and be able to use them without having to go through the trouble of making the graph yourself. So there's some common patterns in polynomial graphs we want to be able to see. So I gave an example here of just a random polynomial. Just this problem isn't terribly important in of itself, but I want to just point out again what the degree and leading coefficient are, in case you guys have forgotten. Remember, the degree is the biggest exponent we have on our variable here. So our degree in this polynomial that I gave is 4. 4 is obviously an even number. If you have an even degree, the end behavior in your polynomial is going to be one of two things. You could either have a situation where it's going up on both sides, or you could have a situation where it's going down on both sides. So both ends go up on the graph or both ends go down. This should actually make sense to you guys if you think about it. We've already talked about quadratics, parabolas. Those are even degree because they're x squared. Parabolas always go like this or like this, so that go both up. They either point up in both directions or point down in both directions. So if you know a polynomial is even degree, we would be able to eliminate a choice. Maybe with some crazy looking graph like this. This graph would not be even degree because it's not going, one end goes down, one end goes up. It has to do the same thing both ways to be even degree. Similarly, an odd degree is going to be a polynomial where the end behavior goes in two different directions. So we'll have one end going down and one end going up. So either looking like this, or it could be the other way around. So the f of x is going in two different directions depending on which way you go in the graph. We've also talked about odd degree polynomials, a line, y equals mx plus b. That's like an x to the first power. Remember, those go in two different directions like this. We'll learn shortly about cubic graphs, which go like this. They're going in two different directions is the big thing. So these would all be examples of odd degree. If you have a positive leading coefficient, so the degree is the biggest exponent, leading coefficient is the number in front of that. If it's positive, that means that our graph, as we go further along, is going to be going upwards. So like if this, we know this is already ax squared right here, the a is going to be positive because it's going upwards. It's the same sort of deal. So if the leading coefficient is positive, we know it goes up. We don't actually know what's going on with this one yet, but if we know the degree, that'll be fine. So if it's a positive leading coefficient, the graph goes up on the right. So it goes up to the right. And if we have a negative leading coefficient, negative a right here, you're seeing it's going down right there. So we don't necessarily know what's happening with the left side, but we know it's going to go down on the right. This is stuff that you'll see through examples. You've got to become very familiar with just seeing these things and knowing what's going on. They're not too bad to remember, but it's important. Let's try a few examples, or actually, I'm going to make a little table here, and that'll wrap up this video. So this table is going to be really helpful. This is something you're going to want to reference and look back on and make sure you know. We're breaking it up by the degree and by the leading coefficient, whether it's positive or negative, whether it's even or odd. So this first box right here is when it's even and it's a positive leading coefficient. Even means it's going to make a U. It's going to go in the same direction. If it's positive, the right side has to go up. Well, if the right side has to go up and they have to do the same thing, that means this side's going to go up as well, because even they're going to do the same thing. So this would be an example of one. You'll find that as you draw more polynomials, they'll get there are extra lumps in them. I don't know if that's the right way to call it, but you're looking at things like what you see right here. These are all examples of even degree polynomials with positive leading coefficients. If you were to just make the leading coefficient negative, still even, remember that's going to make it go down on the right. Well, obviously if they're doing the same thing, it's going to go down on the left as well. So we're looking at stuff like this or like this. You guys get the idea. So negative makes it, just flips it over, just like with parabolas. It works with higher polynomials as well. Now, if we have an odd polynomial with a positive coefficient, positive leading coefficient. Those have to go to the right on the way up. So we know it's going upwards. It's odd though, so they have to go in two different directions. So this could be something like this. It's going up to the right, but it's odd, it's going in different directions. It could be just a plain old line. It could be something with multiple bumps on it, like one of these. Those are all odd with positive. And that leaves odd with a negative, which is going to be going different directions, but going down on the right. So things like this, or let's see, just make something really crazy here with a bunch of bumps on it.